All right, so this is another requested video, and in this problem, well, first off, it's in Danish, but we can figure out what's going on. We've got proton NMRs, we've got chemical reactions. We don't need to worry about what the actual question's saying. We can clearly see that's in D2O as a solvent, so that's cool too. But in any case, what we're given here is some unknown compound B. It reacts with lithium aluminum hydride to form this compound A, which we know, and we're also given the proton NMR for compound A, and we are also given the proton NMR for compound B. So using this information, I take it that we are supposed to figure out what the chemical structure for compound B is, and we can go ahead and do that. But before we do that, I want to talk about this proton NMR for compound A, assign all of the peaks, and sort of just talk about my strategy for that. So the first thing that I would do is I would look at my actual molecule. So if you're given a molecule, the first thing that you want to do is sort of break that molecule down and label the different protons that we're going to see there. So what I'm going to do is in green, I'm going to indicate my different protons. So when I do that, that indicates each one of these is going to be a hydrogen. And I'll label these as A. So that'll be my hydrogen A's. No protons over here. I'm going to have two protons here and here. These are going to be equivalent, so we've got a mirror plane of symmetry, so this one proton here, those will both be equivalent. And I've got two more protons here and here. So my B's, those should integrate to 2. My C's, those should integrate to 2. And we're going to see some splitting here, right? B is going to be split by C, C is going to be split by B. I'll talk a little bit more about that when I'm assigning the spectrum though. On my chain here, so I've got, we'll call these D, E, and F. So my methylene linkers CH2, CH2, CH2. So 2 protons off of each one of those. And then obviously my OH here, FG, we'll call that G. We should have one more proton for that one. Okay, so now looking at my NMR spectrum, I'm going to start assigning things. And right off, I see this pretty tall singlet, and pretty clearly I think that is A. This would be integrate to 3. I've got 3 different protons. It should be a singlet. There's nothing adjacent, so it shouldn't be split by anything. It comes at about 3.8. That seems reasonable for this methoxy group, so that CH3 bonded to an oxygen. So pretty clearly, I think that that's A. The next thing, I guess we could just go down the list, B and C. So for B and C, these are going to be in the aromatic region. So aromatic region's out here, so around 7. That's where we're going to find things on our benzene rings or things like that. And these should integrate to 2 high doublets. So this B, there's 2 of them. They should be equivalent. And then I say a doublet because each one of these B's is going to be split by C. So we're not looking that there's 2 C's or anything like that. We're just looking on the adjacent carbon, how many protons are there. So from the point of view of this proton B here, it's going to be split by this proton C. So I should see a 2 high, and then each one will be split. It should be a doublet. So I'm going to say that these are B and that these are C. I'm choosing that, and I guess I could be wrong, but I'm choosing that because of this oxygen here. It's going to be pulling electrons away. So I think that these would be more downfield or slightly downfield than these C protons. So I'm going to label B more downfield than C, and I can see that these are doublets. And there's also this effect that's called roofing. So these are sort of leaning towards each other, and if you see that, that indicates that those protons are splitting one another, that they are, next to one another, and they're actually interacting with one another. So that's a roofing effect that we can also see there, which is pretty cool. All right, next, D, E, and F. So now for D, E, and F, I think the easiest one is going to be E. E should be a multiplet, so I've got splitting from both F and D. So we're going to, really we could call it a triplet of triplets. But it's going to be pretty complicated, and it should integrate to 2. So I see 1, 2, 3 more peaks. These should all integrate to 2. They seem about the same height as B and C. So this one's the most complicated splitting. We're going to call that one E. It's also the furthest up field, and I would say that this E proton is being sort of shielded by D and F, so I would also expect that to be the most upfield. So pretty clearly I think that that's E. Now for these two, both of these should be triplets. So if I look at F, F should be split by E. Since there's 2 protons here of E, then this F should be split into a triplet, so N plus 1, right? If I've got 2 adjacent protons, should be split into a triplet. Same with D, there's no protons here, and I've got 2 E protons, so E is going to be splitting both of these into triplets. So 2 three high triplets. So clearly this is D, or D and F are here and here. Now choosing which one is which is maybe a little bit confusing. I'm going to put this one as F and this one as D. And the reason I'm choosing that is because F is bonded to an oxygen. Again, that oxygen is going to be shifting it downfield. So now I've just got G left, which is this one high singlet. It's probably going to be broadened a little bit because it's bonded to the oxygen. We're going to get some exchange there, especially if we're in D2O. So this tiny little peak here, that's going to be my G. That's going to be my OH peak. Okay, so that's assigning this first spectrum, and I think that's a great exercise to do. So now we're given this NMR spectrum, and we need to sort of take this NMR spectrum and figure out really sort of how it's related to this spectrum, but also what a plausible structure should be. So the things that jump out at me initially on this spectrum are this 3 high triplet and this 2 high quartet. So I can see that the pattern here is 4 peaks and 3 peaks. So pretty clearly to me, these are new, right? So I can see these are the same, right? They look the same. This 3 high singlet, that's the same. I've got two high peaks here, and they look like triplets. So those 2 high peaks, they could be some combination of these F and D, probably, maybe F and E, if it's been shifted. But this 3 high triplet and this 2 high quartet, those are definitely my new peaks. If I see a 3 high triplet and a 2 high quartet, the first thing that I'm immediately thinking is CH3, CH2, right? So something like this where we've got R bonded to, obviously the R is not going to be a CH2 group because we're only split this into a quartet, but something like this where I've got 2 protons here that are being split into a quartet and 3 protons here. So this is sort of a common motif for an ethyl group. So I think that's the thing that sort of jumps out at me. The next thing I'm going to do is I'm going to look at this chemical reaction, and I'm going to say, well, what other chemical reactions do I know with lithium aluminum hydride? Did I learn about anything recently? And what I actually did is I've looked up in my textbook reactions of lithium aluminum hydride. Those are obviously going to go along with sodium borohydride. And the one that really jumped out at me was this ester at the bottom. So this ester at the bottom, if I take this ester where this R group would be, could be my ethyl group, and I react with lithium aluminum hydride, I'm going to get this primary alcohol. So this sort of, when I looked through this list, what are the different reactions that I could have that might fit sort of nicely? That ester is the one that really jumps out at me. So looking at that, the way that I would go about this, I would start by saying, well, let's just make a guess. And I think that this is really the hardest part of doing problems like this is sort of making a guess and then going for it and sort of seeing where that leads you. Because, it's hard to make guesses. It's hard to sort of do that. But make a guess and then go through and sort of check, does it make sense? If you find something that doesn't fit, that doesn't make sense, well, then you can make a new guess, right? But you really sort of have to put yourself out there initially and just sort of go for it. So this is going to be my guess. Hopefully it's a good guess, right? And I'll label these A, B, C, D, E, F, and G. So I've already talked about this F and G, so I would label this as G, I would label this as F, and then because we have an ester, right, that prevents any further splitting of this F protons, so it would end up as a 2 high quartet because of the splitting from G. Because G is a triplet, because G is 3 protons, it's going to split F into a 4 high quartet. Blech. All right, clearly this is A. Because I've got my same thing here. B and C are really the same as they were before. So I've got B, again, I'm going to put down a little more downfield. Now for D and E, again, I think we could sort of go either way. I'm going to guess, that D is going to be the one that's more downfield because it's bonded to the phenyl green, and then that these would be E. Everything sort of makes sense. These are triplets, so I see a triplet. So for D, it should be a triplet. For E, it should be a triplet. This first guess was a good first guess. And if your first guess isn't a great first guess, that's okay, right? but you really sort of have to make a first guess and then sort of break it down, see if it all lines up and makes sense. If you have further questions about this video, if there's something that isn't clear, or you think I've made a mistake, let me know, and keep studying.